numbers represent. So each one of these areas is kind of like a neighborhood or a community with a fence around it. So if we thought of this sort of like a map, okay, what the 10 is telling you is then within this round fence, within the fence that goes around A, there is 15 homes. Okay, in the fence that goes all the way around B, there's 8 homes. Okay, in the fence that goes around all of it, there is going to be 20 homes. 10, 5, 15, 18, 20. All right. So when we're shading these things to kind of identify the areas that belong to the values, okay, so this has got 10 things in it, all right? The way that you designate that, the notation that you use, is if right below this, if I wrote N, and then in parentheses I put capital A, that's saying how many items are in set A. And in this case, there is 15 items that are in A. Okay? So everything that is circle A, I shaded. Easy. Everything in A gets shaded. Okay? Now, the number of homes in B, in circle B. So those values, that would be a total of 8. All right? So that just looks like this. Pretty simple. Okay, now the word complement. Okay, we use it a lot in math. There's the complement of an angle. If an angle is 60 degrees, its complement is 30, so that these add up to 90, complement. Or I could say something nice, like, oh, that's a nice haircut. That's a complement. Okay, but in set notation, a complement is everything outside of the set. So there's lots of different notation for it. All 3 of these mean the same thing. So this little apostrophe, the squiggle, or a little c as an exponent all stand for the word complement. This is 3 different ways that it might be written. So when you see that, you're saying to yourself the word not. So this would be not set A. So it's everything outside of set A. Okay, so everything outside of set A would look like this. Okay. And if we wanted to know, okay, how many homes are not in A? Okay, so the number not in A. So that would be 3 and 2. And then this would, the complement of B is simply not, we read it as not B. And that would be everything outside circle B. Okay, and the number of elements in outside of B would be 12. 10 plus 2. So that's what the term complements stands for in the context of set notation. And this would be 10 plus 2, 12. All right, so that's what's meant by the word complement. Okay, now you have unions and intersections. So think of the union as you're uniting. Both forces or both neighborhoods are coming together, okay? Even though there are some that are in both. So when we see a U, that symbol, means union, and you can think of it as you're uniting. You're uniting forces. Okay, it's associated with the word or. So it's things that are in one set or the other or both. Okay? So that's going to be the red and the blue, these two just combined. So there's going to be one part that's colored twice. That's the intersection. So here's red. All the forces of red assembled. And all the forces of blue assembled. And so the number that is in the union of these, A or B, okay, is going to be 10 plus 5 plus 3. So 18. So just think, when you see a U, think of uniting. You're uniting forces. Okay, and when the U is upside down, that represents the word intersection. And that is associated with the word and. So here are just the items that are in both, which is simply the intersection. So it's in A, and it's also in B. Okay, and the number of elements there are going to be A and B. All right, so real straightforward set notation. So we use these Venn diagrams to figure out probabilities. Actually, you can do a lot with them. They're pretty clever little invention. Okay, now our next one here. So when I see the little squiggle or an apostrophe, okay, these are both the same thing. So if it said A unified with B and it had a little apostrophe, it means the same thing as this. Or if there was a little C written right here, it means the same thing. Okay, so when I see that little squiggle or apostrophe, that stands for the word not. So anything that's a not is outside. So all we're going to simply do is take this drawing right here, and color in everything that's outside of those two. And then the number of items of not A or B is 2. Anytime you see the little n, it's talking about the number or how many are in there. Okay, so this other one here is not the intersection. So now that's everything outside the intersection of these two. I picked an ugly green. Jade. I'm a little disappointed with jade. Looks like a green from 1970s. You know one of the crazy things they did in the 70s and late 60s with carpet? It reminds me of green carpet in my old house. People would carpet their ceilings. Why? Don't know. Elvis did. I went to Elvis's mansion in Graceland. He had carpet on the ceilings. So people wanted to be cool like Elvis, I guess. True story. Carpet the ceilings. I think Elvis did it so that if you were, playing music in your house, that, kind of, block the sound or, so it wasn't so bouncing all over the place. But it was a popular... This green reminds me of fuzzy, ugly carpet. Back then, very stylish. Right now, gross. Or, popular upholstery color in your cars. This kind of green. Yeah. Okay. So let's see. The number of values here in the complement of the intersection would be 10 plus 3 plus 2, 15. Okay. All right, now this next one here, we are unifying not A with not B. So when you unify, you're combining, okay? So when I see this symbol, okay, I'm thinking of combining the shaded areas. When I see the intersection, I'm going to shade the overlapping parts. Areas or parts, okay? So remember, we're unifying our armies. Unify. Okay, so we've done each one of these individually. Now we're going to combine them. So when you look at this, here's the one that we're doing. Okay, we want to do not A united with not B. So here's not A. Okay, here's not B. Okay, so this is where this kind of comes in handy to help you visualize it. So if I took my not A and I shaded it, okay, there's not A. And now I put that over not B. That shows me what should be shaded. So everything's going to get shaded here except for the intersection. It's either blue or red because I'm combining them. So it's going to look like this with only the 5 unshaded. So if you notice, it looks just like the one you did. So these two look alike because they're the same. So the number of elements not in A united with not B is still 15. So these are the same, even though one is an intersection and the other one's a union. Okay, and here's why. Think of that little squiggle like you're multiplying through a negative sign. So if I took the intersection of A and B and I negated it, watch what happens. If I distribute that through, sort of like a negative, that becomes not A. When you negate an intersection, it becomes a union. I flipped it. Not B. So that's why these two things are the same. So this is the same as not A, flip your sign, union, not B. And this one here is the same as not the intersection of A and B. Okay, so these two squares are the same result. So let's see, I'm going to save this one right here. Is the same as this one. And the same thing happens with these two. These two are going to be the same. If you think about taking this and distributing it, that becomes not A. I flip the union into an intersection, and then that's not B, which is what I got down here. So this would, if I undistributed it, put it back, it would look like this. Not A, not B. So that's going to look like this. So these two guys are the same. Okay. All right, we'll stop there. We're just about out of time. And we'll pick up with this tomorrow. When we're done with all this, the assignment for this, guys, is attached. Right here. Okay, any questions? Questions you have from at home?
None right now.
Okay.